Hey guys, this is Pandit back again with my MATLAB video tutorial series. I am using MATLAB version 7.8.2 R2009A. You can find more about MATLAB software. If you don't know, you can go to the link I will be posting in description. So there will be some video, 5 to 6 videos, which will be I will be showing from basic to intermediate mode. I am also not an advanced user. So this first video, which is the basic video. Who don't know anything about MATLAB can do everything about MATLAB. So just take a look on the MATLAB window. This is the first window which opens. This is our command window where we put commands. This is command history window, where is these are the histories given which I have used earlier, the command I have used earlier. You can access them from here directly by just double clicking on them. Here is the command, or just by pulling it out and dragging it here. Just click enter, it gives the values. So CLC is a command using for clearing the screen. Here is the workspace. Workspace give all the values of the variables or functions or anything you define. It also gives the file stored, it gives the values, minimum, maximum, and that all. For example, this is f I have defined in last. This f is from 0 to 10. It gives minimum value 0, maximum value 10, and axis, which is the sign of f, it is from -1 to 1 roughly. Alright, so MATLAB we can use. How we can use MATLAB? MATLAB we can use as a super calculator. For example, I just type in 2 plus 3, it gives directly answer is 5. Alright, so for example, this was just basic operation. We can also use minus, multiplications, etc. 3 minus 2 multiply by 2, and it gives values. This runs on board mass rule, so it multiplies 2 into 2 first, 2 into 2 4, and 3 minus 4 is -1. So we get our answer. So if we want to multiply first minus 2 from 3, so 3 minus 2, we have to put it in brackets, then multiply the answer by 2. Just hit enter. It gives 3 minus 2 1, 1 into 2 2. Alright, so I will talk now about array operations. Array, you will be familiar with arrays and vectors, so I will be giving you directly how we can define the array. For example, I am defining array name x. X is equal to, in square brackets, you must type in your digits of digits which should be in array. For example, I want 1 2 3 in array. 1 2 3, spaces in between, and hit enter. It gives the array. This is the row of an array. If we want a column array, so nothing, we have to just change it like this. For example, I am giving it y is equal to, in square brackets I want 4 5 6 in columns. So 4, this semicolon, 5 semicolon 6. Semicolon is generally used for terminating anything or any sentence or any particular command. So here it terminates the row. Directly we can use here these are the rows. If we are not giving any symbol in between, just a single space, that means it is continued in row. If we are using termination semicolons, then it shows that it is in column. I hit enter, it comes in column. Similarly, I can use it for making a matrix. For example, a 3 by 3 matrix. So for row I want 1 2 3, first row 1 2 3, second row 4 5 6, third row 7 8 6, 7 8 9, sorry. So I will define a matrix by A is equal to, for row I have to just give spaces, 1 space 2 space 3. I have to terminate this row. So now 4 space 5 space 6, second row terminated, 7 space 8 space 9, third row terminated, hit enter. You get a matrix of 3 by 3. And you can see here on my left hand side, here in workspace, the values which we are defining here, for example x and y, this comes like here, the x value of x is 1 2 3, y is 4 5 6, like that, and value of a is also given, which is the latest value of a. Right, so what happens when we multiply arrays? So we can use it as a super calculator. So let's try multiplication of array. So x and y are some array we defined earlier, so I'm multiplying x into y. Hit enter, it gives answer 32. Yes, it is correct. It just basically works on principle of matrix multiplication. So it multiplies 1 into 4 plus 2 into 5 plus 3 into 6. It gives you answer 32. But what happens when I multiply y into x? It gives another matrix, because it does not it is 1 cross 3, 3 cross 1, and it gives 1 cross 1 for this, and when we take it opposite, so it gives 3 cross 3 for this, so it gives a new matrix. I don't know how it actually came, but it gives you another matrix. Alright, so if you want a row from 1 to 5, you will not waste time for writing 1 2 3 4 and 5 separately. So just use 1 semicolon 5, enter. It will give 1 to 5. 1 is your initial value, 5 is your final value, so it will give you the values from 1 to 5 by difference of 1, which is the default difference. If you want to change the difference between two digits, so you can just use a is equal to 1 semicolon, in mid you have to type in the difference. For example, I want difference of 0.5 semicolon 5, hit enter. You get 1 1.5, 2 2.5, 3 3.5, 4 4.5 and 5. So this is the basics. So for example, if you want like ones in a row, for example ones in any column, I want ones in any column, so I can just write a is equal to ones simple brackets 1 comma 5. Here 1 is rows and 5 is column, so if I am gonna put this command, then it will take only 1 row and 5 columns, so it will give ones in all in 1 row. Same I use for a is equal to ones in 5 comma 1, so it will give me 5 rows and single column. Yes, it is giving me 5 rows and single column. So for example, here we are using ones, we can use zeros too. I'm using zeros. Zeros 5 comma 1, I want all zeros in 1 column. Here it is. So let's move ahead. Let's try solving some algebra. Before that, we can say that if you forgot something you have defined earlier, for example you forgot the value of f you defined earlier, just type in whose, it will be showing you all the values which you have defined. For it will just showing you the workspace. Here it will showing you everything of what's in the workspace and with its size, values, everything. Alright, so let's try some algebraic operations on MATLAB. So for solving algebraic equation, for example equation is x square minus 2x minus 4 equal to 0. So we have to write it down. So first I will define the symbolic symbols which I will use for I am using x and y or just x. So I will define symbol y as y ms x, hit enter. It will be defined here that x is any symbol for solving equation. I will define function solve in single quotes, x to the power 2 plus no minus, what was the equation, 2 into x minus 2x minus 4, I think it's fine, equal to 0, hit enter. yeah, it gave me answer. These are two values of x, 1 minus 5 to the power 1 by 2, 1 minus 5, root 5 and root 5 plus 1. Right, these are equation. I'm not gonna solve this equation. So now we come onto differentiation. If we can solve algebraic equation, so we can solve differentiation and integration, partial differentiations also. So let's come to differentiation. I will be defining sims y new function, right, and I want a differentiation of y to the power 3. So I'm just gonna give diff, which is an inbuilt function, diff y to the power 3, hit enter. You get answer 3 into y to the power 2. Yes, this is our answer. Alternatively, you can use a function for this. So if we use a function, if we make a function for y to the power 3, we have to use an new command which is called inline command. So for example, I am giving function name h is equal to f is equal to inline in single quotes, what's my function value, y to the power 3 space comma no space, without a space you have to write the variable which you are using, that is y here, hit enter. The function is defined as fi is equal to y to the power 3. So we can just use diff here, diff in bracket, and we are using function of y, hit enter. It gives us the differentiation 3 into y to the power 2. Alright, so for higher order derivative we can use differentiation with another command. For example, we use like this, and just by adding some attributes to it. For example, I use here 2. I want 2 times differentiation of this. It gives me answer 3 into y, which is 3 to the power, which is the differentiation of 3 into y to the power 2. Alright, we can use higher order differentiation too. For same as for integration also, we can use int function, which will integrate this, right. So for function definition we have used the inline function. So I think now you can solve many differentiations, differential equation, algebraic equation, matrix, and functions too. Alright, now we can further move to exponential function. For example, we have to find some value of e to the power something, right. So we can use as t is equal to, I am defining the value 0 to by the gap of 0.1, difference of 0.1, 0 to 5. Terminate here because I don't want to see different values, and x gives exponential of t, e to the power t, right. So I want to plot a graph for this from t varying from 0 to 5. So I'll be plotting graph, plot x, or just we can use plot t comma y, t comma x, anything x comma we are just using for graph x comma y, so here we can use t comma x. I'm just trying it, what happens, let's see. Yeah, here is our graph. So this is starting from 0 to the value 5. On 5 we can see that it's approximately 150, and for if we are plotting this, we can just write another command, grid on. It will give us the grids too. Alright, here is our grid, so we can find the particular value. We can just check the values here. Alright, so this was our main exponential function. So if I have defined here by exponential by x, if I want to find the value of exponential at 1, I can write x1, hit enter, it is 1, but it is incorrect. We should get somewhat value 2.7, around 2.7, so it is incorrect. It's giving us incorrect because this is not a function. We have to define it as a function by using this command f is equal to inline, and in bracket here in place of y to the power 3 we can use exp and whatever we are using. So exp in bracket t, this is our function. Here I am using t, hit enter. So this is a function f t is equal to exponential t. So for the value of f at 3, hit enter, its value is 20. Alright, so we can find the values by defining the functions. Alright, so now we come to the point sine and cos waves, tan waves. And we can make we can plot several waves here, because matrix can be used for different operations of signal processing, image processing, lot of operation. There is no end to the MATLAB. So for example, if we want to plot a sine wave from 0 to 2 pi, I define a function omega w is equal to from 0 by difference of 0.1 to 2 pi, 2 into pi is already defined here. I am going to terminate. If I am not terminating here, it is giving me lots of values with on each and every instant. On 0 omega value is 0, 0.1, 0.2, 0.3, it will be giving me a whole lot of value. It will be quite messy. I will terminate this, hit enter. So now I have to define sine, I have to plot sine. So it's either way that you can plot sine directly by using plot command, or just put the value of sine in some different function. Here I will show you the both of the methods. So example, v is equal to sine of omega, terminate, hit enter. Then we have to plot the graph, plot v. Right, it will be good. So from 0 to 2 pi we are getting this graph. Let's have a grid on so that we can see it clearly. Yeah, there are quite error because of these values. These are not perfect values. We can manipulate it with this manipulated graph. Alright, so this is for sine, and for directly plotting we can just use here plot. For example, I am using cos here, cos of omega, hit enter, and it gives us the plot graph of the cos. Right, so plot function can be used in this type of ways. And my last topic will be the plotting graphs. We have just seen a plot function for plotting the graph. There are several functions like stairs, stem, bar, etc. for graphs. So this was plot graph, this is for continuous graphs. Then there comes stem function, which is used for just discrete, we can say discrete or discrete values. So I define two values, x is equal to from 0 to 5 by the difference of 0 to terminate it here, and I define a value y, which would be a exponential function of x e to the power x. Right, so I'm going to stem it using stem command, stem x comma y, hit enter. Right, we are getting this type of graph. So if we would write in place of stem plot, just hold on a second, we have to hold on the graphs. We'll write hold on, because we have to edit in that graph, the same graph. Plot x comma y comma, I'm using different color here, color is red. So you can see here, this is the red line for the plot. The red line indicates the graph which is given by plot, and the blue lines are for the stem. So we can also use bar here. Hold on, bar we will be giving y. Alright, for bar we'll be giving just value y, bar of y, comma what color, y, I think. Alright, it's giving me values of the bar graph because the bar have some values here. Just hold on, I will give you x comma y, hit enter. Alright, from 0 to 5 it's giving the values. So we are writing stem, minimize it, then hold on, then we are writing plot for plotting the graph for the continuous line with red color, and we are using here bar x comma y with the yellow bars. Right, so we can see our graph here. We can't see the blue line because that's hid behind the yellow bars. So this is our graph. These are the three ways of the expression, basic three ways. You can find more in the help. Right, so here was the main thing about for example, here's plot. This is used for defining this like attribute of the graph. I want the graph in red color, blue color, yellow color, anything, or I want star to be printed or dotted to be printed in graph. Hit enter, you will get a graph with dots. Right, so if you want a graph with stars on it, I put a star in single inverted comma, hit enter, you will get stars in the graph at the exact points. If you are using actually I will take from history. For example, value of x is this. Just hold on a second. Value of x is that I will be defining this. X is 0 to 0.5 to 4. Right, if we are giving x value by the difference of 0.5, the graph will be not so curvy because the difference is large, so it will be plotting a straight line across it. We can see like this, plot sine x, hit enter. These are the straight line in this, so we have to use as much as minimum we can use. So I usually use 0.5, so just using plot, it gives a nice curvy and a smooth graph. Right, so and just last thing which is left is for example, we are plotting any graph and I want to show this is my x-axis, this is my omega axis, or anything like that. Then we can use the labelings for the graph and the titles for the graph, which you can find x label, and here you can enter whatever label you want. Right, so for more information you can check the history or the help or the doc. Just hit enter the doc command and it will be giving you every information on MATLAB. Just search results, go to search result, search any document you want. For example, I want help on image acquisition. I'm searching for it. It's giving me a lot of different things for IMAQ. Right, so thanks for watching. I think you have learned something. So I will be posting a new video for the college file. Alright, thanks.